Okay, hello everyone. My name is Andres Alvarez, and I work in the web platform team in Adevinta, Spain, as a front-end engineer. My talk is named Mission Impossible Performance Culture, and today I'm going to explain you how we improve the web performance in Fotocasa. But before getting on with the mission, let me tell you how everything started. So in September 2020, I joined Adevinta Spain in the Recommerce product team. So basically, we needed to migrate Milanuncios from being in a PHP monolithic stack to a React server-side rendering application. After 2 years, 2 good years working in the product team in Milanuncios, I got bored of doing the same thing over and over again. So I was kind of up for a new challenge. So a position was open in the web platform team. So I decided to apply. And 1 month later, in October of 2022, I joined the web platform team, giving special support to the real estate vertical. So to give you a little bit of context, in the real estate vertical in Spain, we have two main web applications, Fotocasa and Habitaclia. If you live in Spain, you probably should know them. So we use React, not Angular, and we do server-side rendering. But instead of using a fancy meta framework like Next.js or Remix, we use our own framework that was developed in Adevinta Spain all time ago. And it's more or less like Next.js or Remix, and it's focused on just allowing the product teams to ship code to production. Okay, so I remember that when I joined, the engineering director of real estate, he was, "Hey, Andres, I need to talk with you." And he told me this. So the main objective of Fotocasa is to increase our SEO traffic. And I heard that performance matters a lot. So at that point, I knew that I had a mission, but I was kind of scared, okay, when he told me that. But why? Why I was so scared? So let me explain you. I thought about a few problems when he told me about that mission. So the first one was that I had no product context at all. I was just getting started. I was a Fotocasa user though, but I didn't know all the features that it has. I didn't have that product context. So another thing is I didn't know the code base. In Adevinta Spain, we use like the same foundation for all our web applications and the same set of tools that is Sui, the one that I told you, but it was like a completely new code base to me. And of course, I was the new guy. So the real estate vertical in Spain, it has more than 6 feature teams and 15 front-end engineers. And of course, the performance problem. So I remember that my manager, the engineering director, showed me this dashboard that is Google Search Console. I don't know if you know it, but there is where you can see how your SEO is working. So there is like a performance tab where you can check the performance of your website, and it's divided in mobile and desktop. So he showed me this, and there are three like colors here. The green is good URLs, the yellow is URLs that need improvements, and the red is poor URLs in terms of performance. So as you can see here, there were a lot of yellow URL, and the mission was making all of them green, okay? So obviously, the more good URLs you have, the better SEO ranking factor you're gonna get. So the mission was pretty clear. But at that moment, I thought like, I'm just getting started. I had all these problems. This looks impossible. And then I was like, okay, let's calm down and take a step back and think about the problem that I need to face. So I thought, okay, how Google measures the performance nowadays? So Google measures the performance with a set of metrics called the core web vitals. So what do they represent? What these metrics represent? They represent a facet of the user experience that is measurable in the field and reflects the real-world experience of the users. So these metrics are about the user experience. They measure the real user experience of the users. So at that moment, these were the core web vitals. So three metrics basically. LCP, that is largest contentful pane, that it represents how fast your web loads. FID, first input delay, how fast your web responds to the first input that is made or the first interaction. And cumulative layout shift, CLS, that is how visually stable is if your web in terms of layout shifting. So let me explain you a bit of for each metric. So the first one is the LCP, and here we have a CNN website loading, and this happens when you go to the website and you hit like enter. The first thing that you're gonna see is like something that is gonna be the first contentful pane, and then suddenly things are gonna start appearing. For example, the title, and then an image. As you can see, the image is the largest element of everything that appears above the fold. So this image is going to be the largest element in the screen. So also that is going to be the largest contentful pane element. So the faster the browser renders this element, the better is your LCP gonna be. So your objective here, or the objective, is to render this as soon as possible. So I need to. Okay, so CLS is visual stability. Here we have an example. When you click no, I don't want to buy it, go back, and then it shifts, the UI shifts, and you click by mistake, buy. And it's so annoying. It happens to me a lot of time. And it's all about making your web stable in terms of layout shift. So before getting started with the interactivity metrics, let me explain you about the main thread, because it's really important. So the main thread, what is the main thread? So by default, the browser is going to use a single thread to run all the JavaScript that you have, to perform layout reflows, layout changes, reflows, and garbage collection. So the main thread is going to be that single thread. And here we have a small screenshot of the main thread in the Google Dev Tools that I took. And as you can see here, the first thing that we see is a task. A task is a discrete word that the browser is doing. And below that task, we see that some scripting is happening. In this case, the handler of a click event. And we see all the functions that are being executed. Okay, so now that we have clear what is the main thread and what is a task, let's review the FID. So the FID is, we're going to have here the main thread, and the FID is going to be the time from when an input is sent to the browser, let's say a click, till it can start be processed. So if the main thread is busy with a task, then the browser won't be able to process that event. And that delay is going to be the first input delay. And this only matters for the first input that is made when a user navigates to a website. Okay, but at that moment, I realized that, hold on, I read an article about Google, and I realized that the FID, the interactive metric, was going to change by a new metric called the IMP. So I thought, okay, we need to be prepared. Okay, so this IMP metric is called interaction to Spain. And as the other metrics, it has some thresholds, and we needed to reach the good threshold. So the first input delay, I was thinking about the change, and I realized that it totally makes sense because the first input delay, that metric only measures the first input. So to measure the real user experience, you need to measure the every single interaction, every single input that is made in the browser. So that's the reason why I thought, okay, this makes sense. Um, but I needed to understand that. I needed to understand how IMP worked to be prepared to improve it. So IMP is going to be the sum of three things: the input delay, the processing time, and the presentation delay. These are the subparts of the IMP. So the IMP is going to count for every single input that is made in the browser for every single event, okay? So that's really important. So the input delay, this subpart, is going to be from when the input is received till it can be start processed. So it's this time here. So if you have a blocking task, then it cannot be start processed, and then that's going to increase the input delay. And then you have the processing time. Everything that you do in the event handler, like when you have an on click, on key press, or whatever, that's going to be what you have here in the processing time. And the presentation delay is that normally in processing during the event handler, you do some changes in the DOM until you do the changes till they are rendered in the screen. That's going to be the presentation delay. And the AMP is the sum of these three, as I said. So during the journey of the user is going to interact with a lot of elements, right? And a lot of IMPs are going to be recorded. But the one that is sent to the Google database, the performance database, is going to be the worst one. Okay, so at that moment I felt ready, but I needed to establish a plan to accomplish the mission that I needed to solve, right? And I remember this quote about Peter Drucker that it was, if you cannot measure it, you cannot improve it. So I thought, well, I remember that we have some dashboards in Datadog, like with a cron job, with getting lighthouse metrics. So I thought, okay, perhaps this could be useful, but I realized that a lot of developers, they were like, I see that the CLF, for example, is perfect in Lighthouse, but in the Google Search Console, it's not okay. And why does it happen? So this happened because Lighthouse uses laboratory data. Laboratory data is basically you running some tests in a specific environment. That's what Lighthouse is doing. But we needed field data. That is the way that Google measures performance nowadays. So I thought like, perhaps we can just use the PageSpeed API and that's it. So in PageSpeed, you can place a URL here, and it's gonna get everything that you see here if there is data. Then you can filter. It's gonna use this data is gonna come from the Crux, the Chrome Web Performance Database. You can filter by mobile and desktop. That's perfect because it's what we see in Google Search Console. You can filter by this URL, the performance of the URL that you are searching, or the whole domain. But it has something that I didn't like, is that it has a 28 time frame. So it's not like you cannot query the performance for the day before, okay? And also you cannot cluster URLs. Like you normally want to, I don't know, if you have a listing page or a detail page, you want to gather all the performance information, okay? So that's what we needed. I thought, okay, but Google Search Console also provides you with performance information, but it's the same. It has this 28 days time frame, and it also doesn't cluster the URLs like we want. So we needed something else. We needed real-time data, because if we chip something, we wanted to chip something and know if it was improving the performance or getting worse the performance right away. It was so important. So we use a library called Core Web Vitals that is made by Google, and we set up this dashboard in Datadog. So in this dashboard, we had like from the router that we have, all the pages to filter, for example, listing, detail, home, the device type, and also we had all the fancy like deployment lines, colors, and so on. So it was really, really handy. Okay, but now that we have the data, that we know the metric for each kind of pages, uh, but we don't know where the performance issues are. So we needed something else. And for that, we used another dashboard, this time in OpenSearch. And we collected every single element that was causing performance issues. So here you can see that you can filter by mobile and by the path in the router. But more important is that you have like the target of the element that is causing the issue. So it was so easy to copy paste it and look for it in the web. So at that point, I felt that we had a plan. So and the plan was start sharing knowledge with everyone in the teams about web performance, doing some presentations, workshops, and sharing stuff in Slack. Track the core web vitals like we were doing it, and take decisions based on data. And I started working alongside one of the feature team that it was the Attract team in Fotocasa to find performance issues and fix them. Okay, so in January of 2023, we started shipping web performance improvements. And we started focusing on LCP and CLS because we thought that were easier to fix, okay, than the interactivity metrics. But at that point, we needed a way to find easier issues in locally and reproduce them. So for that, we started using this cron extension that is called the Web Vitals extension. So you just install it, and you're going to have the core Web Vitals locally. So that's perfect if you want to reproduce a performance issue. This is an advice. You can go to auction, and then there is this property that is console login that is going to show every single thing that happens related with the core web vitals in the console. And it's really useful because it's going to tell you the metrics, and also you can expand it. It's going to give you the subparts and the element that is causing the issues. And here you have both. The thing that you need to enable, that is the console login, and of course the metrics. Okay, another thing is that you can use snippets. This is a website that a friend of mine made, Joan Leon. And here you have a bunch of performance snippets that you can copy paste to the console, or you can add as snippets in Chrome. Okay, so basically, if you go here, for example, you have CLS, LCP, and you have more interaction stuff, a snippet that you can copy paste. Okay. Okay, another thing that is really useful is the Chrome DevTools. We use a lot the Chrome DevTools to debug performance issues. For example, here I have one that is for I was debugging for the IMP. But one thing that you need to do that I think that is important is that normally the developers, we develop stuff in a really nice computer under a really nice network. So an advice will be slow down the CPU, and in some cases try to throttle the network. So to find IMP issues, I would highly recommend to slow down the CPU by 6x. And then you hit record, and then you start interacting with the website. And here is pretty useful because you're gonna see the event here, and it's gonna basically tell you the subparts about the IMP. And it's really important to know which is the subpart that is causing troubles, because you are gonna be able to prioritize where you need to do the fix. And yeah, so basically those two things. Remember the 6x slowdown, and that in every single, this case is for the IMP, but you also have something similar for the CLS and the LCP. Okay, some advices or things that we did to improve the CLS. Okay, so in terms of images, we had a lot of images without width and height or an aspect ratio. So we try to focus on that, adding for every single image those two things or an aspect ratio. Uh, we try to avoid, we replace a lot these JavaScript breakpoints, or in React, this hook use media breakpoint or whatever, because since our application is using server-side rendering, it's really hard to tell in which device you are in server-side, in which the width and height of the screen during server-side rendering. So in this case, we just use CSS, and that's it. And for content that is being lazy loaded, remember to preserve the space, especially for advertising. We had a lot of issues because advertising, the ads are normally filled in client side. So remember to preserve the space. And if not, if the ad is not filled, perhaps you can show a placeholder or something else. So the LCP. So we try to identify the LCP element for every single page. And for that, you can use the Core Web Vital Station, the DevTools, or the snippets that is shared. If your LCP element is an image, remember to preload it. And don't lazy load it, because if not, the priority that you're going to have in the browser is going to be low. So always preload the LCP element to be rendered as soon as possible. And optimize it. So if it is an image, compress the image and search the image for the best image format for that specific browser. Okay, so at that point we improve all that, and now we needed to face our biggest challenge, FID and IMP. Okay, so if you look for this on the internet, you're probably gonna find less JavaScript and optimize long task. Yeah, that sounds easy, but it's hard. I was like looking at the code, I don't know what to do. So here you have what we did, and it worked really well. So first things, if you're using like a UI library like React or a framework like Vue, try to avoid re-renders as much as possible, because they add scripting to your code. But not, I mean, React is supposed to be fast. Re-renders are not bad. Try to avoid unnecessary re-renders, okay? State allocation, place the state as close as possible to your components, because if you place it like too high, then when it changes, it's gonna cause unnecessary renders of several components. So there are also, like, if you have states, be in mind that use them when they are truly needed. Don't, there are some that you can compute on the fly, or you can, for example, just use ref if you want to preserve a variable between renders. Look for expensive renders. So every time your application, a component re-renders, what you have in the render function is, it's going to be executed. So if it has a high time complexity, then the performance is going to be worse, because you are going to have basically more scripting. Okay, so this is something controversial that we did, and it's about UI UX changes. So in Fotocasa, in the detail page, we have the first element that we have is a big image of the real estate. So users were clicking too early to that image. So because the application was iterating at that moment, and a lot of scripting was happening in the main thread. So we thought, okay, perhaps we can tell the users blurring their image that the interaction is not, the image is not interactable yet. And we did that. And it looks like doing some kind of a trick, but at the end, it's being honest with your users that this is not ready yet. So prioritize painting. Try to avoid long tasks, and you can break the long task in the main thread by using set timeouts, or you can use the scheduler API. This basically is gonna delegate the execution of that task, of that code. This is something that you can do, for example, for the tracking. You want to prioritize UI changes. You don't want to prioritize tracking. So This is something that we made, and it was really useful. Optimize third parties, of course. You can load them when for example, in Next.js, there is this after interactive that is, you can load third-party code when the page is partially hydrated, or you can load it with this other strategy that is called lazy onload, that is when the main thread is idle, okay? And we apply many more. And if you want to know which other strategy that we applied, you can just talk to me in the networking, and I will tell you more. So we, after some months working, we realized that something was not working. So it was like we look at the dashboard and we were almost back where we started for most of the metrics, as you can see here. So we chipped some stuff, we improved, and then we went back. And at that time, I wondered why this is happening. We invest so much time and effort to improve the performance. And I realized about something. So more features is gonna be more code, and then you're gonna get worse performance. If you don't take care about performance, if you don't have this performance mindset. So at that point, I was like only working with a team. So I thought, okay, we need to work with all the product teams that are involved shipping code in Fotocasa. So, but how can we do it, right? It's not that easy. So I needed to establish a new plan. We established a new plan. This is the version 2 of the plan. So instead of just sharing knowledge with the developers, we started sharing knowledge with the product owners and the engineering managers, and showing them that the performance is important. Instead of just having this dashboard and just me looking at the dashboard and being worried, we said, okay, let's try to set the performance metrics as health metrics for the teams. And instead of working with just one team, with one product team, I started working with all the teams, and all the teams were involved of working in the performance. And what do you think that happened after? Yeah, so we made it. But what about IMP? We were like, I was in the previous one, like showing you the FID, but we were like also preparing for the IMP. We were like really, really, really red, and we improved a lot, and we have improved more, and we are in the yellow threshold right now. So we were like really happy. And what about the Google Search Console? We started seeing the change in the trend. So we started having more green URLs than yellow URLs, okay? Take into consideration that this takes more time to be updated than the other one, because the other one is real-time data. So from 16 URLs, which could core web vitals, we moved to 100% good URLs. Okay, but what about SEO? We got almost 20% more clicks compared month over month, okay? Okay, but just let me clarify something. I like to think that the performance helped a lot regarding this SEO, but we also achieved a lot of SEO focused features, okay? This is like the sum of a lot of work we have made in Fotocasa. But I like to think that performance work improve a lot. So in December of 2023, we got 100% of good URLs in Google Search Console. So I remember that during a management meeting, someone said, okay, but how can we prevent web performance degradation? I was like, that's really nice question, but we were prepared. So we set up some alerts, and we try to spend some time setting them up, because the alerts that are triggered, and it's like they are fake alerts or false positives, they are gonna just cause noise, right? So we spent a lot of time setting up the alerts for every metric. And we also, of course, added some bundle size check in the PRs. For that, you have you have the Webpack action, GitHub action, and also you have a size limit action. Okay, so some takeaways. So more features, more code, more performance if you don't invest in performance culture. So all product teams should be involved, not only developers, also engineering managers, products, even analytics people, everyone, okay? Backends and so on. And I think it's about this, I mean, as a solo person, you cannot fix the performance of a web application that is maintained by several people. All people should be involved, so it's a change of mindset. And that's it. I hope you have liked the talk. Here you have my Twitter account, my GitHub. I do a lot of open source. For example, the size limit action that you saw and the maintainer. And I have a bunch of stuff in GitHub. Okay. Yeah. Thank you so much.
Thank you. Thank you for the talk, Andres. And now if you have questions. Yes. You raised first.
Thank you. Amazing talk. What you did makes me really happy. Do you know what made the difference? You said involving all the teams finally made the dashboard move into the right direction. And before you were only working with, what was it, the front end team?
Yeah, like Fotocasa. It has like more than 6 feature teams, and each feature team it has some front end engineers. So I was only working with one feature team, and the other ones weren't involved. So they were shipping code without taking into consideration the performance.
Okay, so this was everyone front end, but you only worked initially with one front end team.
Exactly. Yeah.
Okay, cool. Thank you.
No worries. Thank you.
Hi. Just related to bundle size, I was wondering if there was anything special you did with, for example, third-party libraries and trying to reduce that load.
Yeah, this is something that we did. You know that in Webpack you have Webpack bundle analyzer, and also think if you have a library with size limit, you can check the bundle size. So we try to find for quick wins, but it's really hard. Like it's really hard to make the bundle size remove stuff from the bundle size. It is being used. You can challenge. Perhaps we found some duplicated code. I remember. But yeah, I think that most of our work wasn't focused on reducing the bundle size. This is something that we try, but it doesn't impact that much. Like, I think that it's more important doing the other thing than just the bundle size.
Right. Right. You mentioned there's a trade-off between adding new. The screen flickered off. Okay. You mentioned there's a trade-off between adding new features and focusing on performance. Did you pay any attention to how much speed trade-off you had to do between like going faster and going faster?
Okay, okay, I get it. Well, I will say that the teams started looking at it when they were developing features, but it's something that we are working on it. So I wouldn't know how to answer you right now. Like, yeah, we have invented time, invest on extra time, but I don't know about the trade-off, you know. But of course, there is a trade-off because if you develop something new and you take time to measure that everything is in place and work fine, yeah.
Hi. Hello. Amazing talk. About the useless re-render, did you thought about putting some state manager like Yotai or Justan, whatever? And another question, and then I finished. Did you thought also about moving expensive logic inside a web worker?
Okay, the first one, we don't use like a state management library because most of our state is like handled in the page. We only the themes that we share across pages is the authentication, and that's it. So we mostly focus on like trying to allocate the state as close as possible to the component where it is being used. And also, yeah, that's basically it, I would say. Yeah, we didn't use it because we didn't have something like Redux or something like that. And about your other question, yeah, we thought about that, but we haven't tried. And we have some colleagues from Subito that tried, it's like the Wallapop in Italy, and they tried that and they had great results, but we haven't tried that.
So, sorry, we after the talks, we're gonna have a networking session, so you can reach out to Andres and ask more questions, and maybe he can give you like a more in detail answer. So we need to move along. So big round of applause. Come on.